What is going on with this compressor? What you're looking at is a VFD, or variable speed compressor. In this video, we're going to take a look at what exactly that is and why you would use one. First, let's look at a typical on-off compressor, specifically a scroll compressor. Let's look at the internal components, how that works, and we'll compare that to a VFD-driven or a variable speed compressor. Okay, so here you're looking at a very common scroll compressor. If you were to look inside of this, you'd see the motor just about right here. Here is your suction line. Inside around here would be your scroll plates where the compression takes place, and this would be your discharge line. If you've never seen what the compression looks like, the scroll plates inside of a scroll compressor, they look like this. They look like this right here. And what happens is this top fixed scroll plate sits atop the bottom orbiting scroll. Let's look at this and see this in motion. All right, so if you were to take the top of this compressor off and look into the compressor here, you would see the animation all the way on your right. And what's going on here is you have your suction line, your gas coming into the scroll plates. Now you'll notice there's some color changes here. And what's happening is the cooler, or the blue color, represents a cooler gas at a lower pressure. As you move through the scroll in this direction, you come to the hottest, highest pressure point right here. Okay, so I've paused this animation. What you'll see here is the gas comes in, starting here, and look at all the volume that this area fills up. The metal comes together here. Now, then it gets passed through the next volume or area of the scroll plate, which is less than the previous one. There's a metal to metal here. And this is smaller, smaller, smaller. So what's happening in the scroll plates is it's bringing the gas, it's compressing the gas. It's a compressor, right? So it increases the temperature and pressure as it moves through the compressor, and then ultimately will discharge out of the top here. All right, so back to the animation. What do you notice about the compression? What do you notice about the motion of the scroll? The important thing to note here with a typical scroll compressor is the speed is always constant. It's a constant speed to the compressor. With a VFD compressor, or a variable speed compressor, also referred to as an inverter compressor, the speed of the motor can be changed depending on the load in your system. So this animation here is obviously going really fast and really slow. It would be more of a slower and steady ramp up and ramp down. But this is just to show you that it's changing speed. You can notice atop here are the scroll plates that we looked at earlier. This is obviously your motor area. Here, a few things to point out. With this particular model of compressor, and this is a Copeland version, and there's a lot of different types of variable speed compressors. This one is a VFD driven by Copeland. You will have an electronic expansion valve with this type of compressor and an external VFD. All right, so what's the big deal? Why do I want to change the speed of a compressor? Why do I care? Why don't I just use an on-off? It seems simpler. Well, here's why. The two main reasons you would use a variable speed compressor is for precise control. If you're trying to control temperature and humidity, overall load conditions in a space, if you can vary the compressor, it's very easy to do that. The other reason is for efficiency. If you're exactly matching the load that you need, you're only using the energy that is required to meet the design intent. So it's extremely efficient, which is shown here on this graph. So if you've been in the HVAC business a while, you know variable speed motors help with efficiency. Okay, so let's look at some data here. So this is water-cooled chillers, IPLV. IPLV is the integrated part load value, and that has to do with a weighted efficiency over various loads of the chiller. So it takes into account full load and part load. This gray is a standard on-off compressor. Then you have a tandem assembly, which is basically two on-off compressors put together on the same circuit. And then the blue represents a VFD-driven compressor. And as you can see, the efficiency increases in this direction. What about rooftop units, packaged rooftop units? So IEER, Integrated Energy Efficiency Ratio, again, is a weighted efficiency over various loading points of your packaged rooftop unit. In this case, And you have your standard on-off compressor, which is the lowest in terms of efficiency. Then you have a tandem, which is a step up because you'll have two compressors. And then you have the VFD-driven compressor, which obviously is the most efficient because you're able to match your load precisely. So here's another chart which illustrates the importance of matching the load. Here you can see 100% loading example. You have the VFD compressor here and the standard on-off here. And you can see they're both pretty much at full load using about the same consumption, 5100 RPM. Let's say this system went down to 25% load, which is noted here. It looks like about 3 tons-ish, something like that. Your VFD compressor would be able to ramp down to the precise RPM required to match that load, whereas the on-off compressor doesn't have the ability to do that, so you have all this extra power you're consuming. You'll also have issues of short cycling, which is really a big problem for when you're trying to control temperature and humidity over all load conditions. Your compressor is going to come on, it's going to immediately overcool the space, it's going to shut off, and it's not going to do a lot of dehumidification. So there's a lot of other issues here that come into play. Okay, I hope that gives you a general overview of the VFD or variable speed compressor. There is another type of technology called a digital compressor, or often referred to as a variable capacity compressor. That's a totally different scenario than what we just went over here, but we've done plenty of videos on that. So follow us, subscribe, and you can learn more about the VCC compressor as well.